started. For now, we'll go a little bit slowly. So, welcome back to our Java Level 2 class. Today, we're going to start a new unit, which we're probably going to continue talking about this for the rest of Java Level 2. So, it's going to be a big unit. But before we get to that, as usual, I want to go over the homework and just some review of what we did last week. So we talked about exceptions in Java and how to handle them. Specifically, we learned the try catch and finally construction. So uh, that's a way that we can handle exceptions so that our program doesn't just crash. It can recover from it and um, do whatever is appropriate to recover from the error. So I have a couple of review questions on slides. So I'm going to start sharing my screen, and then we can talk about the homework afterwards. So I'm going to share this. All right. So I just have two quick true-false questions. So um, let's just talk about the first one. Maybe in chat if you're available. Think about this first question and you can just type what you think in chat. So true or false? The order of except statements matters in a try-catch block. I guess this should really say catch. Jerry says yes or true. Angela also says true. Right? Ethan says true. Okay, so I think we have a bit of a consensus. So I guess a follow-up question. I agree. The answer is true. Thank you, Henry. Yes, the order does matter. Can anyone explain to me why? Like, what happens if we change the order around? What could go wrong? Like if I have a general catch statement for any throwable exception, and I put that at the beginning of my catch statements, why is that bad? Yep. Thank you, Jerry. Yeah, the try catch is very similar to like our if, else kind of idea, right? So we just have a bunch of cases and we go down in order and check, okay, does it fit the first case? Yes or no? If it does, we go in and we do whatever is inside that code block, and then we ignore the rest of the cases. The same thing is with try catch. So if we have a very general catch at the very beginning, then a lot of things are just going to get caught by that. And it's not going to look further down for any like more specific catch statements. And we talked about how there's a whole hierarchy of exceptions. We have like unchecked and checked exceptions, but specifically we have kind of this ordering of like we have runtime exceptions, and inside the family of runtime exceptions, there's specific ones like arithmetic exception, which came up when we did division by zero, right? So an arithmetic exception is a runtime exception. And so you have to make sure you catch them in the right order where you do the most specific first and then most general at the end. Then I want to move on to the second question. So we said there's also this thing you can do with finally statement, and I just have a true false. It says the finally statement only runs if the try block finishes with no errors. So is this true or is this false? Angela says false. Aaron says false, question mark. Jerry says false. Looks again like we have consensus, which is great. Yes, the answer is false. Thank you, Henry. Yeah, so the finally block, the finally statement, we said this, you can include this, you can leave it out, it's optional. But if you include it, it represents code that should always be run, whether there's an error or not. And we mentioned this is useful for like things like cleanup. We talked about a specific example where, if you have a scanner trying to read open a file and you aren't, something goes wrong in the middle, you want to make sure you close the scanner always. And so you could put a close statement there, something like that. Other examples might be like, again, if you're doing stuff with files, if you're like, if you have a program that's writing some output to a file, um, maybe if something goes wrong, you want to make sure that you end up deleting the file so that you don't have like a half finished output later on. It's just nice to have this filing structure where you know that no matter what, this is always gonna. Right. So that's a review. I'll go over the homework really quick. So basically, the homework for last week was building off the previous one, which was this program where it asks you for a file name and then prints out the contents of the file. And what I said for last week was, I want you to modify this so that if you type in a file that doesn't exist, instead of crashing, it will just ask you again. And it'll keep asking you until you give it a valid file name. Um, of the submissions I looked at, all of them looked really good. And there were a couple of different ways of approaching this problem. So I'll go over one right now with your help. But if you had a different solution, this is also perfectly fine. There are many ways of approaching this. But first, let's just run like the program normally without any modifications. So this is what we have right now. Ask for a file name. If you do like test.txt, it's able to print everything out, no problem. But then if you give it something that doesn't exist, like, I don't know, I don't have a file called this, it'll give me an error, it'll crash, right? So we want to change this. So approaching this, the first thing that we have to figure out is, well, okay, in this code, what is the line that ultimately causes this crash, right? We need to figure out what places in the code could go wrong so that we can add the try catch around it. So can anyone tell me, you can either give me a file line number or you can tell me like what the line says, but in this code, what's really the problem statement? What line of code here is the one that will like give me this error if the file doesn't exist? And it says 17, the question mark. Does anyone want to back him up or say something else? I heard someone unmute, but I wasn't sure if it said. If it says 16, all right, so it's, I will say it's either 16 or 17. Does anyone want to break the tie? We have two answers in chat now. And I will say one of them is correct. 16, 16. So actually, the line that causes the issue is actually line 17. So Aaron, be more confident. You're correct. One way that I kind of hid this, but if you're looking at your code and you ran it, this red text actually gives you a clue of what line causes the error. And so here it's actually says right here, homework 5, Java :17. This is the line that was causing the error. It also says line 11, but if we say, look at what line 11 is, it says line 11 because this is where we use the method, right? So this method throws an error and we're calling it here. So 11 is an issue. But really, if we dig a little bit deeper, it's 17 that's the problem. It's not when we create this file object. I know it's a little bit unintuitive, but it's not this line, but actually when we actually create the scanner, because here you can create new files in code. You can actually create Java programs to create new files that don't exist yet. And so it's fine to create like this file object, this file variable, if the file doesn't exist. But when you pass it to scanner, you're telling it, hey, assume that this file is here, open it up. And that's where it goes wrong. It says, okay, I can't find this. I don't know what to do. I'm going to crash now. Right? So this is the line that has the issue. Um, so we could just surround this, but it might also be easiest to just surround this entire code. So we have this try. I'm going to put a try around this. And then I'm just going to do a very general catch. I'll do file not found. I'll catch a file not found exception. And then we have the handling of this. So again, this is the line that could go wrong. One method that I saw a couple of you guys did and that I really liked is by modifying this function so that instead of returning void, aka nothing, it actually returns a true false value. And this true false value represents whether or not the method succeeded or not, right? And so if we change this to Boolean, so now it kind of returns it will return a status, success or failure. So we want to return here and we want to return in the catch. One of these is going to be true and one of these is going to be false. So maybe let's just answer this one. The other will just be the opposite. Should I have true false here or false here? If we reach this, is this a success or is this a failure? And it says true. Yep, this is going to be a true. Not capital T. True. Because this is the problem line. If we got past this and we printed out everything, then everything's good. We can return true. It was a success, right? But if there was ever a file not found exception, it would get caught here, and then we want to return false. This represents something went wrong, right? So this method now, instead of returning void, it now returns a Boolean value, right? Either true or false, depending on whether or not printing the file worked. Now we have to modify how we're using this method, right? We said, okay, instead of returning void, it now returns a Boolean. What do we do with it? Well, if we think about what our program's supposed to do, it's supposed to ask the user for input, try to open up the file. If it works, we're done, right? We don't need to do anything else. But if it fails, then we need to ask again and potentially ask again and again and again and again and again. So this should hopefully remind you of loops because we want to do something over and over again. But specifically, the easiest kind of loop to use here is going to be either a while loop or a do while loop. In the past, I said that do while is very useful for user input because when you're doing user input, you always want to ask the user once, right? That's the do part of the do while. You always want to ask once, but then you just have a condition that says, was it valid or not, right? And based on that, you will either repeat the prompt or you will finish, right? So I'm going to back up my words. I'm going to use a do while because I think it's useful in this case. You could have done a normal while loop. This is also fine, but I'm going to do this. So here, sure. So we have the do, which is actually creating the scanner does not need to be in the loop. We only need to do that once ever. But we will prompt the user. We will get what they typed in and try to open up the file. And so now maybe we want to store this into a Boolean variable. Status. And so we can say status equals print file, right? So this will be either true or false. Now, what should our what should our expression be? What it's going to be related to status, but it's either going to be status or not status. So we have to think here. Well, when do we want to loop? We want to loop when print file did not work, right? So if in that case, print file returned false. So if status is false, we want to loop. Because of that, we need this negation here, while not status. And so if now we run the code, we do something like, let's just test it normally, test.txt. Everything worked, everything's fine, the program finished. This is expected behavior. That's what we already had, right? It already worked like that before. But if we enter a file name that doesn't exist anymore, like, see, it just asked me again. I can say the same thing, and it'll keep asking me, right? It'll just keep prompting me. As soon as I give it a valid file, then it will print it out and it will end, right? And that's because of our do while loop here. Right? You could modify this so that it will print out a message maybe is like, oh, the file that you entered is not valid or something like that. That might be a little bit more convenient for the user, but wasn't required of the assignment. So I didn't include it here. But hopefully this was a clear example of how to use like try catch to handle your exceptions so that you can write programs that are able to more gracefully handle exceptions without crashing. Right? And maybe a cool use of the do while loop that we don't see that often. Um, right. I want to take a moment here and see if anyone has questions about the homework or the material from last week. The try, catch, exceptions, the hierarchy, any of that. Jerry asks, what does status do? So status is just a variable that I created in this program. The name was just something I came up with. So if you're confused about that, status could have been called anything else. Could have been called B, could have been called Bob. But basically, what I'm using this for is it's the return value of print file is being stored into status. And this basically just tells me, did print file succeed or not, right? So if we look at print file, it returns a Boolean, and the return value the lines are here and here, right? We have return true and we have return false. So if we look at it, when do we return true? We return true if everything in the try block succeeded, and we get to this point, right? That means that we were able to create the scanner, we were able to print out every line. On the other hand, if this line caused an exception, then we would get caught here and we would return false, right? So this return value is saying, did we print the file or did we not, right? And so that's being stored here. So we call print file, we store the results in status. And then I use status as part of my loop. So I say, okay, well, if it didn't succeed, I want to repeat the loop, right? I want to ask the user again. So I have to do not status because, again, I want to loop when it failed, right? I want to keep asking if it failed. So if it failed, status is false. So I need to like flip that around because it'll only loop if the condition is true, right? So I need to do the negation. Did that help a little bit, Jerry? Or do you still have a question about status? Awesome. Are there any other questions from anyone else? Note is since we've added the try catch, we can now remove the throws declarations because this will never throw an exception. Well, it won't throw a file not found exception at least because we will catch it here if it does, and we will handle it ourselves. We don't need someone else to handle it. And similarly, the main method now doesn't need this throws declaration as well, since any errors would have been handled by someone else. We don't need to have that throws. All right. If there are no other questions, I think this pretty much wraps up the exception section of our class. Yeah. We won't necessarily be talking about exceptions moving forward, but it's very useful to remember the try catch because you're going to see it a lot in real life code. A lot of things that we do, we don't know if they're going to succeed or not. And a lot of times we will need a try catch, especially when we're dealing with input or files or things like that, where it's kind of out of our control. We need to make sure we account for possible exceptions. And so it's definitely going to be a very useful thing moving forward. It's not necessarily the fanciest or the coolest, but it's definitely very useful. Right. With that, though, I want to move on to the new topic for today. And that topic is something called classes. So it's kind of funny. We have a class about classes. But in Java, a class means a very specific thing. And when we talk about classes, we also have to introduce a new word as well. That word is object. You might have heard me say object before, and it might not have been super, like, I might not have been super specific what that means, but we're going to learn about that today. Background. Java is what's known as an object-oriented programming language. You don't have to know what everything means there, but essentially, this means that everything in Java is something called an object. Or most everything that we work with are objects. So for example, when you create like a integer variable x, x is an object. It's an integer object. When we create a string, y is also an object. Right? When we create a scanner, that's also an object. Right? In this case, this is an integer object, this is a string object, and this is a scanner object. Right? Yeah. Basically, every variable that you have in your program is an object. Is a class an object? So classes and objects are very closely related, and we can actually talk about classes right now. So classes, how they relate to this is that classes define the blueprint to create objects. So objects are a little bit more like concrete things that we make and interact with, right? We declare integer variables, we declare strings, and then we can take a string and split it or do like char at, upper, lower. Maybe you've looked at these. We work with objects very directly. Classes, on the other hand, are more of an abstract idea. They're defining kind of how an object should behave. And yeah, it will define all the properties and methods that objects of that class will have. An object is an instance of a class. I will use instance somewhat commonly. And we'll look at some more examples. Maybe this isn't super clear yet, but hopefully with some examples it should help. Again, just some terminology here. I said properties and methods. Methods, that's the same thing that we've been talking about in a previous class. We've seen how to write methods. Yeah, so classes will contain methods. And one way to think about it is methods are like actions. They do things, right? So methods are what a class does. On the other hand, properties are more or less just a fancy way of saying variables. Um, Another term that I will use a lot is called fields. So fields are just basically variables that a class has. They just contain information about the class. So let's take a step back from like computer science and like consider a real life analogy to classes and objects. Um, this is just talking about cars. So a class again is a more of an abstract thing. It's a definition, right? So in the case of a car, the class is like the definition of what a car is. A four-wheeled road vehicle that is powered by an engine is able to carry a small number of people. That describes what a car is, right? But from that description, you can have a lot of different kinds of cars, right? Um, right? You have physical cars, like your family should might have a car. Um, there's Toyotas, there's trucks, there's SUVs, there's all sorts of kinds of cars. Um, and yeah, the objects are the physical things that we interact with. The class is abstract. Another important thing here is that the class is kind of singular. You define the class once, but from that definition, you can create multiple instances, multiple objects from that one class. Right? So continuing this kind of analogy, we said properties, classes have properties and methods. So properties of a car might be the color, the weight, right? Maybe the the size. Maybe we have a length and a width, as well as a height, right? We might have a property describing the current speed of the car, right? Maybe a property containing how much fuel the car has, right? Um, we might have a property describing how many people are in the car, right? Or how many seats it has, right? Things like that. Properties are just values describing the yeah. On the other hand, methods for a car might be like things like park or brake or drive or open the door, open the trunk, right? Um, Pick up a passenger, drop off a passenger. Um, these are things that a car would do, and those fall under methods. Um, I know that this is a little bit abstract still, but are there any questions here about classes and objects? Um, One thing I can do really quick is show examples that we've seen already in the past that we just haven't realized ourselves. So if we look at our old code, we have our scanner example, right? So let me zoom out a little bit and minimize this a little bit. So scanner, capital S scanner, this is a class. Someone defined what a scanner is, what it can do, right? But here we're creating a specific instance of scanner. We're creating one that's reading from system.in. But we can also create another scanner down here. And this one, we're creating a scanner that will read from a file, right? So both of these are scanner objects. Like it's kind of confusing because both of them are called S, but this I could call S2 and I'll change all the numbers, right? So S and S2 are both objects of the class scanner. classes and types are also kind of related. Aaron says, is a class like an idea? And yeah, I would say that's accurate. A class is kind of like an idea of something, and then object is realizing that idea, making it real. Um, this file is a class, and f is an object of that class. Right? And if we look at the slides from before, terminology, int is a class, x is an object of the integer class. String is a class, y is an object of the string class. Before moving on, just like a little bit of motivation. Why do we care about classes? We're gonna see a lot of kind of abilities that making classes gives us, but one idea that I want to reinforce is the idea of not repeating yourself. So this is something that I've said when we did loops. It's something I said again when we did functions or methods. And it's again an idea when we're talking about classes. A class allows us to define a set of fields, a set of properties and methods, and bundle it together. In this way, we can take this one class and create a bunch of different objects of that class without having to redefine the properties and the methods each time. And this allows us also, we're going to see like multiple files. So you can write a class in one file and you can use it in a lot of other files, right? This is again useful for the scanner example, right? Someone wrote what a scanner can do. And it allows us to just use that class to create objects and to use the objects to do whatever we need without having to rewrite what a scanner is, without having to rewrite how to do user input and file input ourselves. So it really is just a way of organizing things that is really powerful. And that's why it's important. So the next couple of slides describe how to create classes. And it's kind of interesting because you might have already realized by now, but we've already been making a lot of classes without really realizing it or realizing what classes are. I'm just gonna go to Eclipse. For example, like every time we've been making a new Java file, how do we do it? We say new class, right? So every file that we've been making has been a class, right? It's not necessarily a fact that every file is a class. You can have files that are other things. We'll learn about like interfaces. That's another kind of idea. You can have a file as an interface, not a class. But everything that we've seen so far has been a class. So I'm gonna create 6 Java, or actually, I think I have a cat example. So here I made a new class called cat. And if we just look at what's auto-generated for us, this is how you define a class in Java. We say public, we say class, and then the name of the class. So public here, I'll start talking about this a little bit now. We're going to talk about a little bit more later. But public just means that anyone can have access to this class. We will define what a cat is here, but we can then use it in any other file that is able to see this. And that's because it's public, right? If we made it like private or some other things that we can say here, we restrict who has access to this class. But class here is just the keyword. You can see it's purple, it's a special thing. Whenever you're making a class, you just have to say class. Not hard to remember. And then the name, By convention, class names always start with a capital letter. It's not enforced, but it's highly recommended and everyone does it, so you should do. Um, the other thing is that when you make a public class like this, you need to make sure that the name of the class and the file name are the same. So this is the cat class, so the file is called cat.java. If we change this to like dog, then we get an error because if we hover over it, it says the public type dog must be defined in its own file. Dog and cat.java, they're not the same name, so it doesn't work. You need to make sure that the names match. So this is how you define a class, but the class is empty right now. There's nothing inside of it, right? We need to add some uh, fields and methods. So fields properties. What kind of fields would we maybe want for a cat class? What kind of things do we need to describe a cat? So maybe in chat, any volunteers? Okay, so close. Furry. Yes, that's like a, okay, so that's like a value for the field or a value for the property. But if we think about, okay, so if we look at this slide, properties are more like this. So this is for the car example. So a property of the car class might be color. And then a specific object will have a value for color. So maybe the color is red, maybe the color is blue, maybe the color is gray, white, black, whatever, right? So the property is called color, and then each object will eventually have a value for that property. So furry or fluffy is more like the value. We're going to the cat object is going to be fluffy or furry. But the property might be like, I don't know, it's gonna be like a string and it's gonna be like the fur type. I don't know. That's just what I'm gonna call it. Right. So string color might also be another one. Um, can we think of a property that wouldn't be a string? And it says double weight. I like that. Right. Um, we can do others if people want, but this is, I think, some good examples so far. So these are our fields for the cat class. And then we want some methods. So actually, not static. Public void meow is going to be one of my methods. And all this is going to do is system.out.println. Yeah, right. That's all it does. So I added a method to this class. So we create this cat, but now what do we do with it? Right. And what we do with it is we want to create objects of the class, right? And so to do that, I'm going to go to another Java file. So I'm going to create a new class, and this is going to be class 6.java. Notice, by the way, in our cat.java class, we did not have a main method, right? This is not something that you're going to run or execute, right? It doesn't really make sense to run this file. This is like a definition file, right? It doesn't do anything if you run it. On the other hand, I'm going to make another file, and this is the thing that you're going to actually run. This is going to be the file where we create cat objects. So I'm going to do exactly what I said. I'm going to create cat objects. And um, we've kind of already seen how to create objects, but I will do it for this first one. So we can do like cat, um, I don't know, call it Bob because I don't know the names. We've kind of seen this before. So this is how you create an object of your class. A note here is that these are different files. So I have cat.java and I have class6.java. Class6.java knows what a cat is because it's just in the same kind of directory as all the other Java files. So it can see the other files in the folder and says, oh, there is a cat.java. Um, there's a cat class defined in cat.java. So I can just look there and I know what a cat is, right? So that's why we can use things like cat here. And the rest of it is should be stuff that's like pretty similar to what we've seen before. We've seen the new keyword used to create things like, for example, new scanner, right? Um, we have parentheses, but we don't have anything inside of it. We'll get to that later. And then we want to store it inside of some variable, some object. So we have the type, which is cat, and we have the name of the variable, the object, just Bob, right? And then I can do like Bob.meow, right? And so if I run this, I get meow, right? And I can meow multiple times and it will print meow multiple times, right? So this is how you create an object of a class and call methods on that class. Can you explain it again? Okay. So from the start, we have this file called cat.java where we define the class. So classes always start looking something like this. We have public, we have class, and then the name of the class. In this case, it's cat. We have a couple fields. We haven't done anything with them yet, but I will. But these define properties that a cat would have: fur type, color, weight. They might want a field for like the name of the cat, right? And then we have methods. So here I just have a single method in the cat class called meow. And all it does is print out the word meow, right? So this defines what a cat is. This is just how I decided to define what a cat is. Then we want to use this class, right? This is just an abstract idea for now. We want to create objects of this class. And that's what we're doing in this file. This first line is how we create an object of the cat class. It's something that we've seen before, or something similar to what we've seen before. The right-hand side of the equal sign is where we create the object. We just say new cat, right? And creates a new object. And then we need to store this into a variable. What is the type of the variable? Well, it's a cat. So we say cat here. And then here's just a name, right? I could have called this C and then C here, C here, right? I don't know. I'm gonna do Bob so it's clear that it's like random. But here we can do the methods. And I will talk about how to work with the fields later. But right now, are there any questions? Because this is kind of the important step. This is where we finally see a really basic class and how to use that class. Yeah. This material is kind of confusing just because it's a little bit more abstract than what we're used to. But we're going to see a lot of practice. And hopefully by the end of this, we're going to be more comfortable. But I want to make sure that if anyone has questions, that I answer them as soon as possible. So I don't move on while people are still confused. Um, so again, I just want to ask if anyone has questions about what we did just now. Um, Aaron, did that clear up your question? Or is there something that you'd like for me to explain more? Okay. All right. All right. Tyson says, wait, how does it print? Okay. So the reason why it's printing meow here is because in the cat class, we defined this method called meow. Yeah. And it does the system.out.println line. And we're calling this method here. No worries if you didn't see it first. But like other examples of calling methods, we've seen this before with like scanners, right? I'm going to use this example again. This line is similar to what we're doing here with creating a new cat, right? So here we're creating a new scanner, here we're creating a new cat. And then with the scanners, we're doing things like next line, because that's what a scanner does, right? It reads lines, it reads ints, it reads whatever. But that's not what a cat does. A cat meows. It might do other things as well. But yeah. So I want to talk about the class a little bit more. We're still going to use our basic class, but we're going to add some things to it. So, well, actually, first, let's just talk about how to work with these properties, because we've seen how to like use the method, right? We just create an object and then we use the object to call the methods that we've defined. But how do we access these fields? So everything is still with this dot character, right? Oops. We use the dot to access the methods, right? Dot meow. We can also use the dot to access properties. So we can access, let's say, the fur type. So bob.fur type. And note that Eclipse is actually very smart. It saw that we created the cat class. It read the file. It knows everything in there. And so in the autocomplete, it actually tells me, oh, fur type is a string inside the cat class, right? It can do that for you. But bob.fur type. And so we want to set this to some value. So previously we said maybe like furry, right? So this is setting a field, right? Bob.furType is basically a variable in the class that we define to be a string. And here we're setting it to a specific value. Yes, so the fur type is furry. We could also do like fluffy. We can do this for the other fields. So if we look back at the cat class, we have color and we have weight. Well, maybe, oh, something went wrong with this. Let me just reset. Sometimes when I double click it will change this. Oh, actually, I think what happened is I dragged it. Okay, everything looks good now. So if we look at the cat class, we have color and weight. Color is a string, weight's a double. So let's do this. Bob.color, maybe it's orange. And then the weight is, well, has to be a double. Maybe it's like, I don't know what cats weigh. Let's see, 5.6. Let's say this is pounds. I don't know if that's heavy or light, probably light. But here we can set the field, right? So this, you can think of it, this is just like a variable that we've been working with before, except now it's a variable specific to Bob, specific to the object, right? And this is how we access, but we could, this is how we store values, but we can also just read them using the same thing. So we can do like system.out.println line, what is Bob's Furry. All right, I'm back. So that's a fur type, and then we can do color, and we can do weight. So this isn't too exciting because we set the values here and we're just printing them back out. But you can see, hey, um, so we can say fluffy orange 5.6. Does the cat file need to be in the same package? I believe so. So I'm not using packages here. I just have default package, but if you put it in the same package, it should work. Um, if it's not in the same package, you can still make it work, but it's more complicated. So I would not recommend that for now. Um, yeah. So that's how we access the fields. Here's like examples of storing values, and here's examples of accessing values. But another place where we want to work with these fields is with the methods. Um, Maybe let's make another method. A cat needs to eat, right? And maybe what eat does is it just increases the weight of the cat, right? So we can do something like this, right? So eat just says weight equals weight plus one. So it should increase the weight by one, right? And so notice like we defined weight here, we can access it directly with the same name, right? Also note inside the class, weight is kind of, again, just an idea. There's no value for weight in the class. Values only exist once we create the specific object. Right? So let's look at that for the specific object. If we call bob.eat, right, maybe we call it twice, and then we print out the weight again, we should hopefully see, yep, we started at 5.6, we eat twice, now we're at 7.6. Right? This is still like a very made up example. It's still very basic, but it's a little bit more interesting now, right? We have a couple fields that we have right here. We have a couple methods, and one of these methods interacts with the fields that we have. Um, yeah. This is a very basic class so far. Um, Again, I want to pause, see if there's any questions that came up from what we just covered. So mainly working with the fields of the class. Make this code a little bit bigger. So here's, I'll put some comments. And if there's any questions, feel free to type in the chat while I write the comments. So yeah, yeah. So this is basically what we're doing here. I want to comment. Okay. So they make a cat object. Um, there are two more things that I want to see if I can cover today. The first is really quick. So a note here is what happens if we make another cat, right? Here we create a cat called Bob, but maybe we want to create a new cat called, oh, Mary. It's another name. So, so we create the second cat exactly like how we created the first one, just by saying new cat. and storing it into a cat variable. And let's set Mary's fields. So maybe Mary is sleek. Um, Mary is black. And Mary weighs, I don't know, 6.4, whatever, random values. What I want to show now is that we can print out Bob's values and we can print out Mary's values. So the Zoom disappeared for a second. And we will see that, you just print some dividing lines really quick so it's easier to differentiate what's going on. That needs to be quotation marks. Sorry about this. So if we run it now, we'll see that here's Bob's information, right? A fluffy orange 7.6 weight. And then we also can print out Mary's information, which is sleek, black, 6.4. So you notice that in the cat class, we define these fields and these methods, but every single object of this class will have its own copy of things, right? Bob has its own color. Mary has its own color. Changing Bob's color does not affect Mary. And this should make sense, right? Like if we think about what these are representing, if we have two cats, if Bob eats, Bob will increase in weight, but Mary shouldn't be affected. They're separate. They're like different, have different values for these fields. So when you create a new cat, you create new versions of these fields and these methods for each one. So I don't think I have time for the last thing I want to talk about, which is fine. We'll continue next week. Um, and just a heads up, so this is class 6. The next 2 classes are probably going to be about classes still, Java classes. There's a lot of things that we haven't seen yet. And hopefully once we see them, some of the things that we've done in the past will make more sense. That's the goal at least. But yeah, classes are what we're going to be focusing on in the future. For homework this week, it's going to be posted on Classroom as always. It's basically just kind of practicing what we did here. So I want you to come up with your own class that you want to make. Do something like this. So don't make a cat class, but you can make something different. And try to make it maybe a little bit more different than this. Like don't just make a dog class with fur type, color, and weight. There's a lot of things that you can make classes about. Maybe you can make a class about a student class. A student has a name, has a grade, has a homeroom teacher, something like that. And maybe it'll have various methods. You can make a class about cars. You can make a class about maybe a food. I don't know what the methods would be, but you could come up with a bunch of fields. But yeah, just come up with a class of your own. I want you to create a couple fields. I want you to create a couple methods, and preferably some of the methods should be like this, where it will interact with the fields a little bit, not just simple print statements. And then do something like this here where we're playing around with the class. So create another file where you create objects of the class that you defined, and then you call the methods, you call the fields like this. And that will be the homework. I know I'm at 8:45 right now, so I will stop with the lesson. Yeah, as always, I'm happy to answer questions that anyone might have now. I'll be sticking around after, but if you don't have any questions, thank you for coming. I'll see you all next Monday at the same time.